Okay, and welcome to the another community call for Dapper on November 24th. Thank you for joining and making the time. This is, at least in the US, Thanksgiving week, so we appreciate people who are kind of calling in. But we do have a few interesting things today. We're going to start with kind of talking a little bit about the recent RC release that was announced last week, and it was a very exciting milestone for us. Then we got Harry from New Relic, and he's going to show us some of the Dapper observability capabilities with New Relic, the New Relic tools and stack, which is going to be pretty cool. Yaron is going to show rate limiting for an application with Dapper. And then we're going to kind of address that, go back to that conversation we had about moving to the Discord servers, because now we do have a Discord server. So we're going to talk a little bit about that. So let me get started. So first of all, as I just mentioned, and I hope you've been following, we reached a really exciting milestone for Dapper, which is the first release candidate for version 1.0. You know, the community has been working really hard on this, and a lot of work has been going into it. There are a few things that I did want to touch on that are important to know about the RC. And let me bring up this. So in the Dapper docs, you'll notice we try to put this kind of all over the place so you can't really miss it. But if you just go to docs.dapper.io, you will land on the 0.11 release, and I hope you can see where my cursor is up here. So because this is a release candidate, the RC1, you do need to opt in and explicitly kind of download and install that version. And you got all those instructions in the release notes of the RC, but also you'll notice, and this is where we're starting to use the new website capabilities that we put in place. We do have an RC version of the docs, and that has basically, if you go to the Getting Started section, you'll see that for the CLI, we actually have the correct command that will let you get the CLI for the RC, as well as once you get to do the Dapper init. So just note that you need to explicitly opt into it. If you just do the regular CLI pull and then just Dapper init, that's actually going to land you at the 0.11.3, which is the latest before the RC. If you want to, and we do encourage everybody to try out the release candidate and give us feedback and open issues. That's a really important part of this process, getting Dapper into the production-ready version 1.0, the official release. And as we're collecting these issues and addressing them, we expect to have additional release candidates in the future, and probably the next one is going to be during December. We do have, at least in the US, some holidays, and of course around the world. But yeah, you can expect possibly in December another release candidate, and we really want the community to help us kind of identify issues, open those issues, address those issues, so everything is welcome. I don't know, Mark, Yaron, if you have more comments on the RC that you want to maybe touch on and speak to.
No, just it's wonderful. Please try it out and give us feedback and raise issues in GitHub.
Yeah, great. And if you want to read more on it, by the way, we have in our blog, we got a nice post that kind of gives a good overview of the release highlight, you know, what it means for the Dapper project, and also some good links to, as I said, the release notes, the getting started, all that good stuff. So feel free to check those out. And with that, I'll actually hand it over to Harry for our next topic, which is New Relic and Dapper.
Excellent. Thank you very much for having me on this community call today. It's a pleasure to be here. I've been following Dapr since the very first time I heard about it from Mark Rusinovich on the Ignite last year. And I have prepared a demo for you today to show you a couple aspects of what the Relic can do, especially with regards to observing a Dapr environment and the application that run on top of that. I'll try to keep it really practical today. So it's a practical guide on how you could use the Relic. I keep it, interactive. I showed command line and stuff to really show you that this is really something that typically works out of the box. I will highlight some sections where I did need to do some minor adjustments, but it's really only a few sections where this is the case. Most of it is really out of the box, which is a really nice experience.
Maybe just to mention, Harry, while you're
pretty much the environment. Oh, yeah.
Oh, I'm sorry. I just wanted to say you put all this good stuff in a blog post, and I'll be pasting that URL in the chat so people can actually afterwards even try it out themselves. But sorry, continue.
Yeah, no, exactly. So I will cover some highlights and scratch the surface on some of the areas. But there is a blog post that shows a very detailed description and step-by-step guidance on how you could achieve the same thing. And thanks for pointing that out, Ori. So let me start with pretty much showing the environment that I place. I hope you can see my screen. Can you confirm, Ori? Is that?
Yeah, we can see it. Yeah.
Okay. So excellent. So what you can see here is basically my Azure account that I put in place. And you can see I already have this AKS cluster that I deployed. It's located in the US region. And also what I did already, because that is really straightforward. And if you're familiar with Dapper, you have done that maybe a couple of times already. What I did already is put in place the Dapper requirement. So if I go in here and do a kubectl get pods, you will notice that all of the pods are running in the Dapr system namespace already. So this is pretty much straightforward. And then, what I wanted to show today is kind of like, how you could get started in observing what the Kubernetes cluster does, and also the underlying applications. And so in order to get started, from a Relic perspective, there is a free account that you can create on our Relic homepage. It is a perpetual license, so it is not a trial. You can use the full platform and can do the same thing. It's just a matter of signing up with your email address. So once you have done that, you can go into your environment and log into your account. And then, what we provided here is a nice way to actually, get started on the platform. So there's this Add More button that you can use to easily get started. And of course, one of the things also is Kubernetes, right? And so this automated installer that we see here right now is basically your starting point in the Kubernetes environment. So what you'll do here is kind of like really just select the Relic account. In case you have multiple, I do have multiple accounts here, so I won't select this here because this will also reveal my license key, which I don't want to show here. But basically, the next steps are that you will just give it a name. Most of our customers have multiple huge Kubernetes clusters up and running. You can specify the name of the integration or the namespace. In this case, I chose Dapr-monitoring. And then you really just specify, okay, which parts of our integration do you want to enable, right? The integration is based upon kube state metrics. Do you want to gather Prometheus metrics, Kubernetes events, and log data? I'll explain what all of these parts do in a little bit. But basically, you choose the install method, whether it's Kubernetes in a manifest file or whether you want to use Helm. You download the manifest and you're pretty much done. As in a typical environment, what you will do, and I have the integration already downloaded. So this is my YAML file. What I can do then is, pretty straightforward. I will do a kubectl apply -f, and then the New Relic manifest YAML, and then you're pretty much done. So in order for this demo today, I also already prepared this. As with the Dapper pods that I already deployed, I also have the Dapper monitoring, and you can see all the different components that are basically part of our integration here. So this is really just the underlying infrastructure, right? So we have the Kubernetes, the AKS cluster, we have Dapper running, we have the New Relic integration running. So the next step is really just to deploy an application onto the environment. And so for the deployment, I selected the distributed calculator, which is part of the quick start Dapper repo. And this also is, really straightforward. I will not go into the details. You can, look at the repo to see install instructions. What I will show is a couple aspects where I needed to do a little bit of adjustments. So basically, if you, got this deployed, you will see this nice UI which shows the distributed calculator. You can try it yourself. If you use this IP address, this will point you to my, deployment here. So I can use the calculator, and all these different operations are basically different, microservices or Dapper applications that run inside of my environment. So one of the aspects, and this is really nice thing about Dapper, that OpenTelemetry is kind of like baked into the underlying system. So what's nice about this is that when each of these services talk to each other, and you can see this is the underlying architecture. There's an application, the adding, the addition function is written in Go, subtraction is C#. So all of these provide just this specific service. And so if I want to know more about the application and what's happening inside of this service, I would typically use an agent to attach to the application that then monitors everything that is happening. With the OpenTelemetry part, the only thing that I really need to add is, and this is what I'm showing here, this is in this case, the C# function, so the subtraction part of the calculator. You can also look at the source code is up on my GitHub repo. What you would typically do is, you would just create this OpenTelemetry tracing and enable this in your startup function. And really the only thing that I needed to do is add this exporter. So we have a New Relic exporter prepared for OpenTelemetry metrics, and you just provide it with an API key. This is an REST API key for our backend. You give it a name, and this is really everything you need to do on the application side of things. So once you deploy this, I can go back to my console here. So I also did this, and if I remove the namespace from this command, you will also notice that these are all the different pods that I have deployed from the distributed calculator. I used the Redis as a state store, and then you see all the different pods for the distributed calculator. And I can also show the services, and you will notice that there's all the different pods for the different services up and running, including the external IP that I have deployed here. So with this, what I really did is I downloaded the generated Kubernetes manifest file. I specified the OpenTelemetry exporter of all the metrics that are gathered anyways. And so with that, I can directly jump into our New Relic platform. And one of the things that is a really nice starting point for this is the New Relic Kubernetes Cluster Explorer. And this is where I jumped in. So if you then jump into the apps section, there's one of the apps is this Kubernetes Cluster Explorer. In this case, I have multiple clusters up and running. I choose to use this AKS Dapper cluster. And this is really a nice visualization that shows you, how's your underlying Kubernetes cluster behaving, all the different aspects of the cluster itself, including, the different nodes that you have as part of the cluster. You will also notice, some, things that are maybe in the alerting stage, or, some having some issues. If you look at the pie here in the middle, you will see all the clusters that are currently running, all the pods that are currently running, excuse me, everything that is maybe in an alerting stage, pending stage, or whatsoever. Of course, I can then also drill deeper into the different aspects. I can look into the nodes, see some host node level metrics like CPU, memory, and so on. I can, even dive deeper if I want to, and look at, some even further details around the nodes itself, even like disk usage, network traffic, and so on. So this comes really out of the box also with the Kubernetes integration. I could even jump into all the events that happened inside of my cluster. You can see there's nothing happened in the last 30 minutes, but if I remove or extend this time window, you will even notice, all the things that are happening in the time view chart, all the things like deploying applications, failed mount points, as you can see here. So, scaling replica sets. So this is kind of like your history of what happened to my Kubernetes cluster. More importantly, and specifically around the application side of things, I can also see the same type of information down below in a more table-like chart. The nice thing about this is I can, sort this. I can, for instance, say, show me the pods that are running against their limits, maybe. So I can, quickly sort and filter this to look at maybe some pods that are currently running against the limits. I can then click on this and see, how did this pod specifically perform? I see the current usage, this blue bar. I can see the limits and the requested resources of this specific container. But also, of course, all the services that are part of my distributed calculator. In this case, this is a pod that is responsible for the adding functionality in my distributed calculator. I can then again see the events that happened for this specific pod itself. I can see, what image got deployed. If I have multiple containers as part of the pod, I can see that, and then I can drill down deeper into the specific areas. So this is really nice way to show you how is your application and your cluster performing. What's nice also is that we try to put everything in context. So what you see here with the See Logs tab, this is something what we refer to as logs in context. I can directly jump from this pod here, from this pod level visibility into the logs that we captured for this specific pod. So really nice, and you can see, there's some activity going on. Some users are adding stuff, and this is really the standard logs that we capture for this specific pod. And of course, all of this works also in a huge environment. It scales nicely. I can sort and filter this if I want to see, only a specific part, maybe only the Subtract app that is running. I can see it only runs on this one node. And then again, I can jump into the details of this specific one. As specifically for the logs that we capture of the entire Kubernetes cluster, there is also a direct jump into the logs itself. So you can use this logs link to jump into just the pure logging information. And you can see, there's all different kinds of annotations available or attributes that I can use to filter, sort my specific Dapr environment. I can also focus on any specific, safe searches that I put in place. So maybe I want to filter only on the Dapr specific parts. This is all available out of the box. One nice thing that I mentioned earlier is also the distributed tracing. So as part of the OpenTelemetry, we also capture the trace information of all the requests that are captured within the application. And this here is now a view that allows me to look into all of the traces that we captured. In this case, I filtered down on my specific host. So the request header host that my front end responds to. And then you can see down below here all the traces. You may be familiar with Zipkin or Jaeger. It's a pretty similar experience here. Again, I can see in the scatter chart all the different traces. You can maybe see and focus on some outliers. This is all with that tiny change that I put in place into the application, visible out of the box. I didn't need to do anything specifically. And then I can, focus on, show me the slowest ones that happened in the last 30 minutes in this case. I can then jump into this specific trace that we captured. You can see this is the trace ID. It took in total 1.04 milliseconds. And this is what happened during the course of this specific trace. If I want to, I can even dig deeper into a specific trace to look in all the in-process information and method calls that happened. Just to show you also as part of the OpenTelemetry, this is also out of the box. I can see this is the front end application making a call to the subtract application using or leveraging OpenTelemetry as a way to instrument the application. By the way, we capture anomalies here, and you can also refer to logs, but this is probably something that goes a little bit too deep for the session today. What's nice also about the platform is that all of the raw data is collected in as part of the telemetry data platform. So basically, all the things that you integrate, will be stored in a kind of like a huge database. We call it or refer to as the telemetry data platform. And the nice thing about this is I can then build also dashboards on top of that. What I did here is I leveraged these dashboards that are also part of the Dapper community. So there is already some dashboards, in this case, focusing on Grafana. But you can also leverage the Relic dashboarding capabilities to create the same kind of experience and showing the data that you captured in nice dashboards. What I did here is I just, adopted the same dashboard to our platform. Another visualization that focuses on the sidecars. So, all of the CPU memory, the Go routines that have been captured, all without the with that out of the box integration. Just to show you kind of like the query builder that we put in place here, this is a way where you could use kind of like our own query language. It's called NRQL, stands for Relic Query Language. But you can also, if you're more familiar with PromQL, Prometheus metrics, you can also use these type of metrics to query, all the different things that we capture out of the box. So everything you see here is being, captured without any additional effort or anything on my end. So I can see what HTTP client completed, requests that we see, the latency and all the different things. So this is all available. And just for the sake of it, I also put this into a dashboard, sorry, that I show here. So this is kind of like, showing all the different aspects. What's nice about this is I can easily correlate all the information and see, is the client request count somehow correlated with the latency or things like that. So it allows me to visually see any correlations also that happen in the environment. But of course, this is not the only place where you can create dashboards. There's also the possibility to use Grafana if you want, right? The nice thing about our platform is that we also provide a Prometheus endpoint. So you could directly use this endpoint to query and gather all the metrics that are stored in our telemetry data platform. I can just simply create this Prometheus data store. I'll give it, again, an API key. And then, without any changes, I could easily, reuse all of the existing dashboards that may be already available. I can then go in here into the dashboarding section. I also copied in these dashboards into this Grafana instance. And so you can see the same type of metrics that we also capture and are available as part of the Grafana integration. And lastly, one thing that I also wanted to quickly show is, if you create the, if you have available, all of the events and metrics, you can also build, and this is typically what customers do, more, business-related dashboards. Maybe they want to see usage of the application, or they want to see, especially now in an e-commerce scenario, hey, how can I correlate my user experience and performance and things like that. So what I did here is I really used these app applications that I deployed on the Dapper platform, and then extracted just the information. And I tried to come up with a winner here on what is the operation that is mostly used in my application. And clearly, I guess we have a winner here. The subtract function is something that is most used by the users of the distributed calculator. And with that, this is really what I wanted to show today. Like I said, we have a lot of information that I captured in the blog post. If you have any questions, you can ask them now. Happy to answer any questions you may have, or we could also, focus on that in the Q&A section.
Yeah, thank you, Harry. And I'm not seeing anything in the chat, but anybody, if you have any questions, feel free to drop them. And as Harry said, we can address them now or when we get to the Q&A part. One thing I know, Harry, you have a PR open to add some of these instructions in the docs. Right now, the docs cover kind of how to gain some of these visualization capabilities with Zipkin and with App Insights and with Grafana and using the Prometheus endpoints. But this would definitely be a nice addition for people to just use Relic as well. So yep. Thank you for doing that, Harry. That's a great contribution. And
yeah, my pleasure.
Great. So again, feel free to drop questions. We'll address them later. But for now, let's move on to the next part. Yaron, take it away.
Yeah, thanks, Ori. So today I'm going to talk about an often overlooked feature of Dapper about rate limiting. So, usually when you have a very highly scalable app, you want to put some kind of rate limiting on. Usually rate limiting is used to protect services in your cluster from things like denial of service attacks, or which is mostly used by malicious actors, or also there's a term called FFDOS, which is friendly fire denial of service, when you have services in your cluster that you control talking to your other services, but they experience a pretty big load and they make other services which they depend on unavailable by hitting on them with a very large number of requests that execute concurrently. So rate limiting is often used and should be used in environments where you have high load on your services, and Dapper has a feature to support rate limiting for your application. And let me share my screen so I can show this. Let me know when you can see it. Can you see my screen?
Yep, we see it.
All right. So inside of our docs, you can find it in the how-to section under operations, configuration, and concurrency and rate limits. And this will basically tell you how to do it. I'm going to walk you through a demo where we take a Node.js app and we efficiently turn it into a singleton. So I'm going to open up VS Code here, and you can see that I have a Node.js app. It's pretty simple, just a web server with an order endpoint, and then we have a set timeout. So after 100 milliseconds, it'll just return a status of 200 OK. And let's see how we can actually throttle and limit the concurrency for this application. So if you recognize this is just a Kubernetes deployment. It has the Dapr annotations for it, nothing really special here. We're telling Dapr to inject the sidecar, we're giving it an ID and telling Dapr what the port of the application is. So I will just apply this to the cluster. And let's go here and wait until it's running. So the node app has an ID, and now we can port forward. So now I'm port forwarding from my local machine to the pod that's running inside of the cluster, and I'm port forwarding to the port of the local Dapper sidecar there. So this is working. I'm going to go back here, and what I'm going to do now is just use AB, which is a pretty standard load testing tool. Was created in 1996 by a guy called Adam, I think, and it's pretty common. It's an Apache project, and we're going to use that to basically create 10 client connections to the Dapper sidecar, and this is gonna make 500 requests. I'm gonna make it 300 because I think we're going to be over time here. And now we can see that it's completing the requests, and in just about a sec, it finished, I think, in under 3 seconds, and we can see the latencies here. Now, let's say that we want to turn this entire app into a singleton. So the only thing I need to do for that is to basically just have a new Dapr annotation, which is Dapr.io app-max concurrency. And I'm going to give it 1. So what this is going to do is it's going to rate throttle all the requests coming to the Dapr instance and by extension to my application. And Dapr will only allow 1 request to come in at any given moment. So we will reapply the node here. And it's configured. And let's wait for it. Okay, so we are up and running, and we can go back here and port forward again. And now if I go back here and I rerun the test, so we can see this takes a whole lot longer because the rate throttling has been applied. So yeah. And this is a pretty useful feature if you need to protect your applications from a high number of requests, or if you just want to have like a singleton type of business logic where you have some data races and you want only one instance of an app to be able to make a request at any given point in time, which is like an actor that's not an actor. Or like I said, if you want to protect your services, both from requests that might be coming from outside of the cluster, or if your entire system is now handling an increased load. With that being said, this feature is pretty basic, and we do mean to extend it. For example, we want to provide support for clients to be able to get a 429 response header from Dapper signaling that the server is busy, so that clients can actually perform their own business logic and apply back pressure or do some other type of load balancing if they need to. And looking into the future, we are looking at making back pressure a more of a core native feature in Dapper, so that Dapper itself will be able to apply back pressure for services that are busy, and maybe do things like latency-based load balancing and other types of exciting stuff. So with that, I am done. Back to you, Ori.
Thanks, Yaron. We do have one question from Xavier. Let me read it out. Regarding rate limiting and malicious actors, I would be interested to hear more about this practice. Where did this Dapper feature originate from? Is this something that happens frequent in production environments?
Yeah, so this happens pretty often. I think if you go to all the major cloud providers, Azure, AWS, and Google Cloud, all of them have rate limiting guidelines for how you rate limit and protect your apps. So like I said, the major use case for this is against denial of service attacks, which can come from people trying to attack your application and make it unavailable, or from other services in your cluster that might get overloaded at any given point in time, and they might be using a service, and then they're making that service unavailable. So this really works for both ways.
Great. There's another question from Tron, but I just see a follow-up from Xavier, so maybe we'll talk about that first. Wouldn't that mainly be caught by an API gateway host over the time?
Yeah.
Oh, most of the time.
So it depends on which API gateway hosts support rate limiting. Some of them do have that, some of them don't have that. But also, you know, if you look at the other scenario where a request already comes in through the API gateway to the cluster to one service, right? So it passed the API gateway, and then that service calls a different service. So that request doesn't go through the API gateway. So in that case, you use rate limiting to protect services after the initial request to the cluster has already passed through the API gateway.
And we have an interesting question about scaling here. So this is from Tron. Is there a metric for pending requests or similar, so we can use Keda or something to auto scale the target app? So
that's a great question, and the answer is yes. So Dapr has a bunch of metrics. You can actually see all of the Dapr metrics if you run your Dapr instance locally or on Kubernetes, and you go to the URL endpoint for Dapr, so 3500 by default, and then /matrix, you will see all of the metrics for it. And Dapr has a metrics, which I can't remember, but I will look it up and paste it here, that does show you the amount of calls that are currently handled by the Dapr sidecar. So yes, you can do that. You can, for example, use the Prometheus SCADA scaler to do all sorts of nice scaling scenarios based on that.
That's cool. And Mark asks, can you talk how the Dapr rate limiting would work with multiple replicas?
Yeah, so actually when you annotate the Dapr deployment, a Kubernetes deployment works with, it basically creates multiple pods. So each pod would get that annotation, which means that the app max concurrency setting that you put on a deployment will actually apply to all of the multiple replicas that you have. And also, I didn't show this, but you can do this with the Dapr CLI. So it doesn't have to be just on Kubernetes. If you go to our docs, you'll see that we have the app-max-concurrency flag also supported by the Dapr CLI. So you can do this thing locally just like you would on Kubernetes.
Great. Thank you, Aaron. Not seeing any more questions on this, but this is cool. Yeah, it's kind of a nice reminder of a feature that has been there for a while, and I think it's good to revisit that and make people aware of it. So thank you. And with that, we'll go to our next topic. So based on some of the discussions we had actually on these community calls, we were talking about like moving away maybe from Gitter to something else, and I'd love to share with you that we have a Discord server now. So you're all welcome to join, and I think Xavier was one of the people who kind of suggested it and pushed it. So thank you for that. And I think this is a great way for us to kind of have maybe a nice and maybe a better platform to talk about Dapper and engage with each other. If you want to join it, we create like this quick link for that. So feel free to use that and join. I think we'll slowly kind of probably wind down the Gitter conversations from there, but for now we'll keep it open and hopefully move to Discord everything. I think with time, while we kind of figure out the way we want to manage some of the different areas, and we already kind of opened channels for different areas of Dapper, we can probably kind of adjust it and tweak it, and maybe there's maybe it would make sense to have some channels that are just for repo maintainers, specific for like triaging things as we kind of open up and people kind of join and have use kind of those different roles in the community. But I think we'll figure it out. Definitely, Discord is a little new to me. I can say, but I love the fact that we're kind of evolving this, and there's a lot of nice features and I can see you guys joining in, so that's great. So keep doing that. Yeah. Hey there, Yaron. Okay, great. So with that, I think we can move on to the general Q&A. So if anybody has any questions, general, feel free to put them in the chat, and also we can unmute you if needed. So feel free to do that. Let me look at the chat right now. I think there's some questions here from George, very specifically. Do you want me to unmute you maybe, George, and maybe we can discuss this instead of me reading all these command lines? Go ahead, George. I think you should be able to unmute.
Yeah, so I read the question. So George, you're running Docker for Docker desktop on Windows, and you're saying that you're hosting the Dapr containers in self-hosted, so locally, and you want to know if using Dapr pub/sub messages will go from one service to another. So my question to you is, you're showing the Dapr run commands here, and so when you say you're using Docker to host the Dapr containers, which containers do you mean? Do you run the Dapr sidecars in containers, or do you run your application inside of containers, or just the Dapr control plane locally? The sidecars. So when you do Dapr run will actually run the binary outside of Docker. So if you're using the CLI, it'll just run the process, and you don't need to run it in Docker at all. So pub/sub should work if you're using Dapr run. If you're using Docker Compose, that would be something different. In that case, you would need to make sure that the Docker network, which you're running your sidecars in, have access to whatever pub/sub component you're using locally, whether it's Kafka or Redis. So if you want to use Dapr with Docker locally, what I recommend you do is you create one Docker network for all of your instances, and you also put the pub/sub in there, and that should basically work for you.
Network in the run command, don't you?
Sorry?
Don't you have to specify the network in the run command if you use the run command still?
So the run command doesn't have a Docker network. If you're running Dapr and your app inside of Docker with Docker Compose, you wouldn't be using the Dapr run command, because Dapr run just runs the Dapr process from your local directory on your machine. So it doesn't run it in Docker. When you do Dapr init, then you need to give it the Docker network. So when you do Dapr init and give it the Docker network, Dapr locally will install the control plane into the Docker network of your choice. So you just need to make sure that the network is there when you start the Dapr init command. But George, you can ping us about that on Gitter, or better yet, Discord now, so we can take it from there. But basically, Dapr runs Dapr outside of Docker. All right, great. I'm glad that's helpful.
Great. Any other questions? I think we'd love to hear from people who may have already installed and tried out the release candidates. If they have anything to share about their experience or any feedback, I think that would be great. Oh, Xavier, do you want me? You're running the RC. Yeah, if you want to unmute.
Yeah, no, definitely. So thanks for unmuting. So the only thing that I'm missing, but I don't think it's related to the RC itself, is that when I update bindings or pub/sub or any other component, that it doesn't get propagated to the containers immediately. So I have to kill the pod and then automatically let it restart, which is kind of lacking, I would say. Also, the sidecar injection is sometimes being odd. Like when I restart the cluster itself completely with all the nodes and stuff, then sometimes the sidecar doesn't get injected automatically, which is normal due to the dependency of Kubernetes. But those are the two main issues I have at the moment.
So did you open an issue on GitHub for that with some steps to reproduce maybe?
No, not yet. I'm going to do that right now or in a bit. I'm still trying to evolve the issue further there because I'm just running it for like 2 days, I think, in production right now. So I'm still waiting for everything to clarify more.
Okay.
But other than that, it's amazing, by the way. I'm going to do a test tomorrow of 150,000 from a queue, and it's like the initial tests are just amazing on how easy it is.
Yes, your first request is the ability to have dynamic reloading of components when they're updated.
Yeah. That would be really helpful because like in development or on dev cluster, I constantly keep reiterating them, but it's, yeah, like you have to kill the pot all the time, which is sometimes a bit of a hassle.
Yep, it's certainly something we've been looking at, and it's come up quite a few times. And we're looking at creating an option where you can choose to have it dynamically loaded if you want.
Amazing, thank you.
The second one about the injectors, when you, if you could maybe run through a bit more details on the scenario, it'd be interesting to figure out, was it you took down the whole cluster and restarted it again?
Yeah, so there was something wrong, so I changed the autoscale group, which completely tuned it down to 0. So of course Dapper is also gone then. Then it restarted completely, and of course, yeah, Dapper takes a while to reload itself as well. So it like the order of component initialization on the Kubernetes part is not fixed. So if one pod that is smaller in size and starts up quicker than Dapper, then it doesn't get the sidecar injected, I saw.
Okay, I think you should raise an issue with that.
Yeah, we'll need to look into that because that.
So did you, Xavier, did you scale down the control plane? Is that what you're saying?
Yeah, so the entire Kubernetes cluster, of course not the master, that's like I'm using a managed master there, but it's running on the worker nodes, of course, but I scaled down all the workers to
All the
0.
workers, okay.
Yeah.
Yeah.
Basically remove the nodes so that there are no nodes left.
Yeah, a good test. I think it's worth something looking at more.
Yeah. Anyone else with feedback on the RC? Any questions unrelated to the RC? Anything at all? Not seeing anything. So yeah, so with that, just another maybe call to join Discord, and we can continue addressing any questions or feedback over there. Thank you for all the presenters today. Really interesting stuff. Again, please, aside from joining Discord, try out the RC, give us feedback, open issues, and keep following us on Twitter, on the blog. And so once we have a new release candidate, hoping in December, you can also kind of get the latest there. Yeah, so with that, thank you very much. And I think we'll close down this call. Thank you.